So Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules then has to pay a total of £600. What is the price of the washing machine with no VAT added? So in other words, this is like a compound percentage problem. The way I use this, I use something known as the present or original value. That is, you can say that the original value times some multiplier must give you a new value. This is a very popular formula. So we just look at what's what. If we're increasing, it will be plus R. If we're decreasing, it will be negative R. As we're adding to the VAT, it will be plus 20%. So 1 plus 20%. Okay, and this means, and the new value we got was 600. So we're just calculating the old value. Okay, so that's it. And now we just solve this one. So what you could do, if you just expand this, or you can just make OV the subject, you can say OV equals 600 divided by 1 plus 20%, which is 1.2. And now you just fix that up, and you're done. So to scale this one properly, without a calculator, unfortunately, you just have to clear the decimal. So times up and down by powers of 10, so times it by 10, and you should get 6,000 over 12. Now you just simplify the fraction. So dividing by 2, you get 3,000 over 6. Half again, you get 1,500 over 3. Dividing by 3, you get 500. Done. Very easy. Other methods are possible, but always start with this unique formula and then just work your way to the end. Alright, number 10. Show that this triple bracket can be written in this form. Oh, so easy. Just expand, guys. So I always start with the last two, just for the sake of simplicity. So expanding the last two brackets, just use a FOIL, so do x times x, x times 3, 2 times x, and 2 times 3. Let's do it. So x times x is x squared, x times 3 is 3x, and 2 times x is 2x. That gives you a total of 5x. And lastly, 2 times 3 is 6. Now, as we're trying to solve this last bit, there's a cool way to present this. Again, let's open up the brackets. So I'm going to change pen. And we can say x times x squared, x times 5x, and x times 6. So call this one the extended FOIL. And do the same with 1, guys. Literally just attach it everywhere. So, and follow this step carefully, yeah? So firstly, let's multiply everything by x. So you're going to get now x cubed plus 5x squared plus 6x. Now, times everything by 1. So 1 times all that. And make sure you line up the powers, yeah? So 1 times x squared is x squared. 1 times 5x is plus 5x. And the other one be plus 6. And then just do a big line. Total this up and press add. Now you just total it up. So you got x cubed makes x cubed. 5x squared and x squared makes 6x squares. 6x and 5x is 11x. And we got 6. And that is your final answer. So easy, really. Whew. So we're in number 11 now. Now, question 11. So the graph of y equals fx is drawn on the grid, which is clearly a quadratic equation, by the way, with a turning point at 1 minus 3. And let me guess, write down the course of the turning point. Well, it's right there. So 1 and negative 3. Okay. Write down estimates for the roots of when the function equals 0. So this means when this equation equals 0 and y equals 0, which is literally the x-axis line. So that's literally over here. So this is one solution and one solution. Now, you just have to be very careful. I'm probably going to zoom in for this one. So here, this looks like, the red line is kind of disruptive, I guess. This looks like it cuts the axis bang in the center between 2.5 and 3, so 2.75, I guess. And this one seems to cut between minus 0.5, minus 1, so minus 0.75. Just take your time and really analyze it, yeah? So you can say minus 0.75 and 2.75. Okay, let me zoom back out again. Now, so far easy. So use the graph to find estimate for the function when x equals 1.5. So notice how x has just been replaced with 1.5. So let's have a look. Where is x equals 1.5? Was there. This is 1.5. So just see when it hits the curve. Well, it hits the curve at this point here. And that seems remarkably over here. So again, zooming in. And that looks like, ooh, so I think it's going up in 0.2s actually. So 2.2, 2.4, 6, 8. So this is negative 2.8. Yeah, well, I'm kind of surprised. This is quite a nice paper actually, not so bad. Anyway, moving forward once more. Ooh, powers, indices. Yeah, I kind of like this, guys. So number 12, find the value of 81 to the power negative half. All right. So first rule, before you even do powers, when you have a negative power, don't think this is a negative solution because it's not. It literally means a reciprocal, so it means 1 over the solution. So whatever your answer is 1 over. So we can quickly say 81 to the negative half is 1 over 81 to the power of half. That's it. Another thing, when you have powers of half, this is literally the opposite of squaring, which is, and the opposite of squaring is, well, square rooting. That's why we have half instead of 2. So square root of 81 is just 9. So the final value would be 1 over 9. Technically, it can be plus minus 9, but it just says find the value. So they probably didn't think about the negative 9 bit. Okay, or you can actually. To be fair, I'll still keep as plus minus. Why not? B. Find the value of 64 over 125 all to the power 2/3. Well, this is similar. Firstly, the 2 here represents squaring, and the 3 here represents cube rooting. My personal advice, do the cube rooting first, because nobody wants to find 64 times 64 and so on. So let's find the cube root of both numbers, yeah? So we can partition this, find the cube root first, and then afterwards square your final result. So the cube root is 64. If you don't know your cube numbers, just start from 1. So you have 1 cube is 1, 2 cube is 8, 3 cube is 27. I'm just going to guess the next one must be 64. The way these papers work is that they usually use numbers which are whole. They won't give you horrible decimals. They'll give you a whole integer. So the fourth cube number is, well, 4. And this one I'm guessing is also 125 because 5 cube is 125. So the cube root of this is 5. And lastly, guys, just square. Squaring both of these numbers will give you 16 over 25. Very easy. Number 13. So now what do we have here? So apparently the table shows a set of values for x and y. Okay. Alright, so for when x is 1, y is 9. And yeah, it seems to be increasing linearly, but this is decreasing in, well, God knows what. Probably inversely or something. Let's have a read. So y is inversely proportional to square x. Alright, so this is kind of those proportional questions. This literally means that y, firstly, is proportional to the inverse of x squared. So 1 over x squared. That's how we begin it. And the way this proportional sign works is that we just literally, this just works as a scale factor. So we can say, alright, y must equal some scale factor k over that. So it'll be k over x squared. Basically, to summarize, replace the proportional sign with equals k. And you're done. Now, this is easy. Find an equation for y in terms of x. Well, y in terms of x, we never said y in terms of k and x. So we need to somehow replace the k and just plug in some values for y and x from the table and find k. I'm going to go ahead and use 3 and 1 because it looks easy. You could use 1 and 9. Do not bother using 2 and 4 because that's horrible. So when x is 3 and y is 1, the equation becomes 1 equals, actually I'm a bit silly here, aren't I? I could use the very first one. When x is 1, y is 9, because then we have 9 equals k over 1 squared, which is k. So we found the answer. So the solution would be y equals 9 over x squared. Yeah, easy. Now, find the positive value of x when y is 16. Again, plug in 16 for y and solve for x. So we've got 16 equals 9 over x squared. Swap the positions because you can multiply x squared across divide 16. So we have x squared equals 9 over 16. And alas, to get rid of the square, well, square root. So the square root of both of these numbers is 3 over 4. Usually plus minus, but the question says positive value, so plus only. So yeah, so far so good, isn't it? Right, this one I heard infamous stories about. This is definitely one of the trickiest questions, but trust me, secretly it's easy. Let's have a look. So white shapes and black shapes are used in a game. Some of the shapes are circles, whereas every single else are squares. The ratio of the number of white to black shapes is 3 to 7. So before we even move on, Let's put 3 to 7 here, and let's call this white and black shapes, yeah? So we have a total of 10 parts, but we'll get to that. Or we can also say 3/10 are white and 7/10 are black. Why? Because the total part is 10 and 3 out of 10 parts is white, 7 out of 10 parts is black. Next one. The ratio of the number of white circles to white squares, sorry. So this is within the white column is 4 to 5. So ultimately we can say for the circles, if the total number of parts is 9, so we can say 4/9 are circles. So 4/9 are circles, whereas 5/9 are squares. The reason why I'm writing this now, because it's best to summarize information before you solve the question. And the last one, the ratio of the number of black circles to number of black squares is 2 to 5. Again, the total number of parts here is 7. So we can say 2/7 are black circles, 5/7 are black squares. So let's do over here. So from 7/10 we can say 2/7 are circles and 5/7 are squares. It doesn't matter how you write this, best to write somehow. Now here comes the ultimatum. Work out what fraction of all shapes are circles. Ooh. Let's have a look. Firstly, we know that of the white parts, 4/7 of the 3 white parts, i.e. 3/10 are circles. Let's write it down. So circles. From the white section, 4/9 of 3/10 are circles. We also know from the black section that 2/7 of 7/10, 2/7 of the 7 parts, i.e. 7/10 are circles too. So let me write it down. So 2/7 of 7/10 are also circles. So ultimately, solve this and, well, that should give you an answer. And that's it, we add them up. So 4/9 of 3/10, you just multiply. So change the off sign to time sign, guys. So I will just delete this, change my color pen to purple and put times. Now, we're pretty much done here actually. So to solve this very intuitively, you could multiply head on or you could simplify. Well, when I look at these numbers, I can see that 3 and 9, when I cross simplify, are both in the 3 times table. So divide them by 3, you get 1 and 3. Divide 4 and 10 by 2, you get 2 and 5. Same thing below. 2 and 10 divide them by 2, you get 1 and 5. 7 and 7 divided by 7, you get 1 and 1. And we're done. So now we decide to multiply. Trust me, it'll help you from wasting time, literally. So multiplying across, 2 times 1 is 2, 3 times 5 is 15. Second one, you should get 1/5. And now we have to add them up. So convert the second one to make it over 15 because it makes life easy. Times up and down by 3, and you get 3. Add these two and you get a total of 5 over 15, or, wait for it, 1/3. Voila. So 1/3 are circles, clearly 2/3 are squares, but we just care about circles. Yeah, so definitely see how it's to double check this question. This was a hard ratio question, or easy, I don't know. Yeah, have a go. All right, number 15. Whew. So a cone has a volume of 98 centimeter cube, and they're kind enough to give you the formula too. The radius of the cone is 5.13. Cool. Work out an estimate for the height of the cone. Oof. Thank God we didn't have to actually work that out. So the volume of the cone, or for the height, okay, let's write the general formula first. The volume is going to be firstly 98 and the radius is 5.13. So popping in the formula, we've got 1 over 3 pi radius, which is what, 5.13 squared, and height we do not know, and volume we do know, it's 98. Now to estimate this, well, you just have to round this up neatly, and we have to firstly assume that pi is 3.14. Keep it like that. So estimating, well, let's have a look. Let's round it all to, let's say, one significant figure. So 98 rounds up to 100 because it's close. 1/3 is kind of okay. Pi is can be rounded down to 3. So 1/3 times 3. So 3 over 3 is 1. So these two cancel out. Now 5.13, that can be rounded down to 5. So 5 squared is 25. And at last we got h. So now you just solve. Divide 25 across and you got h, which is 100 over 25, which is exactly 4 times. So we can estimate the height of the cone, which is 4. Not bad. Now, John uses a calculator to work out the height of the cone, which I did as well too, by the way. Will your estimate be more than John's answer or less? Well, it's actually very easy to know. There's a trick when it comes to fractions. If we rewrote this entire equation using what we had earlier, the actual height would be, using the original formula, 98 over all of these, which is 1/3 times pi times 5.13 squared. Now, one thing to note, if you look carefully, the top fraction is lower for the true value, and the bottom fraction is heavier. This means that the ratio between them is tighter. So if the gap is smaller, we're going to get a smaller answer. The estimate has a wider gap, so we're going to get a bigger answer. So in fact, our estimate is actually bigger. And well, my reasons is literally that. You can just say because the numerator is heavier, so numerator is bigger, 100 bigger than 98, and the denominator, so I'll try dom, is smaller, since 25 is less than, well, we're going to assume pi over 3 times 5.13 squared, definitely. So there's a lower gap. The gap is smaller for the true answer, but the estimate is bigger gap. That's it really.